this video, we're going to discuss another example of using area under a density curve to find probabilities. All right, so let's go ahead and go through this example. A continuous random variable x has a symmetric distribution with mean equal to 50. All right, so this is really important. This distribution is symmetric. Okay, so if I draw out the distribution, whatever it looks like on one side, say it has a bump there, then it also will have a bump here, right? So it looks symmetric. It doesn't say anything about it being a bell shape necessarily, so it's not necessarily this shape. It could be, right? That's symmetric as well, but it just says that it's symmetric. So I just want to draw it, just something that's symmetric. Okay, and the mean is equal to 50. So here in the center is 50. Okay, suppose that we know that probability of x being between 50 and 80 is 0.35. So let me go ahead and draw 80 somewhere. Say here's 80. Okay, and so I know that if I draw this, I know that this area in here, right, must be 0.35. All right, and also I know the total area under this entire curve is equal to 1 because this is a density curve. Okay, so those are the two pieces of information that I guess I was given with this problem. So let's go ahead and determine some probabilities. So let's determine the probability that x is between 20 and 50. So here's 20. So say here's 20. Now this distance here is 30, right? But there's a distance of 30 between 50 and 80. But there's also a distance of 30 between 20 and 50, right? And so since this distribution is symmetric, if that area is 0.35, this area must also be 0.35, right? Because this distribution, if you fold it in half, it should, be symmetric. All right, so actually, well, there we go. Between 20 and 50, it's got to be a 0.35. So the probability must be 0.35. All right, so now what's the probability that x is greater than 80? All right, this is a little trickier. Let's see. Well, so we know this area in the middle, right, 0.35 plus 0.35. So between 20 and 80, this is, let's see, 0.7, right? 0.35 plus 0.35 is 0.7. I know the total area under the curve is 1, right? So 1 minus 0.7, right? Because that's 0.35 plus 0.35 is 0.7. So I know that these two little areas on either side must add up to what's left over, right? So this 0.3. So these two little areas on either side must add up to 0.3. Well, again, the distribution is symmetric. So whatever this little area is, it's got to be the same as whatever this little area is, right? So if it must add up to 0.3, that means 0.15 must be on that side, 0.15 must be on that side, right? Because 0.3 divided by 2 is 0.15. Okay? All right, and we can double check this. So now we've kind of come up with all the areas everywhere in this curve, so we should double check. All right, so does 0.15 plus 0.35 plus 0.35 plus 0.15, does that equal 1? And it does. So, this is good because the total area under this curve should be equal to 1. Okay, so that was a question that says what's the probability x is greater than 80? So that's that little piece right there. So that is 0.15. Okay, next question says, what's the probability x is less than 20? Less than 20, well, that's that little piece right there. So that's also got to be 0.15. Right? Last question says, what's the probability x is between 20 and 80? So that's here, between 20 and all the way over until you get to 80. Right? So between 20 and 80. So we need to add up 0.35 and 0.35. Add up the areas for both these sections. Okay, so that is 0.7. Okay, well, actually, I'm going to add one more. Say you were asked to find the area that x is greater than 20. There's two ways you could do this. One is easier than the other, but let's go ahead and talk about both ways you could do this. The first way you could do it is you could say, all right, so greater than 20, so that's here where I'm marking in green. It's all the way over here, and it's all the way over here, right? So if I were to add up those three areas, that's 0.35 plus 0.35 plus 0.15, right? Which adds up to, so see, this is 0.7, so it adds up to 0.85, okay? So that's one way I could have answered this question, just add up all of those sections that are more than 20. Another way I could have answered this question is using complements, right? Do you remember complements? I'm going to write that up here. So the probability that x is greater than 20 is 1 minus the probability that x is less than 20. Okay, probability x is less than 20 is 0.15, right? That's right here, right? Probability x is less than 20 is 0.15, right? The entire area under this curve is 1, right? So if I just take off this one little section, that should tell me the probability of being more than 20. So 1 minus 0.15, which equals 0.85, okay? It's two different ways to get the same answer. And I would argue that the second way is easier because you're just doing 1 minus 0.15 as opposed to adding up a bunch of different numbers.